بسم الله والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. أهلا وسهلا بكم في ليالي سبرانية المقدمة لكم من الاتحاد السعودي للأمن السبراني والبرمجة والدرونز بالشراكة مع الشريك والممكن الرقمي ATT&CK. الليلة في محاضرة التاسعة وباقترابنا من نهاية المحاضرات التي نقدمها لكم في سايبر نايتس، نذكركم بالمسابقتين التي تأتي تزامنا مع هذه الجلسات. المسابقة الأولى أفضل ثريد مكتوب مستقل عن كل محاضرة تحضرها في سايبر نايتس باستخدام هاشتاج سايبر نايت، والمسابقة الأخرى اللي هي مسابقة الاختبار الشامل، وبعض تفاصيل هذا الاختبار الشامل بإذن الله راح تلقونها على حسابنا في تويتر على حساب الاتحاد السعودي للأمن السبراني والبرمجة والدرونز، كيفية الاشتراك وكيف تسجل وكيف تفوز بإذن الله. كذلك اليوم في محاضرتنا التاسعة نسعد باستضافة الأستاذ فيكي راي، بيكلمنا في Introduction to Threat Hunting Intelligence. المحاضرة راح تكون باللغة الإنجليزية، بس كالعادة أي محاضرة بالإنجليزية بإذن الله راح ننزل بعدها على طول أهم المعلومات اللي طرحت فيها لكم باللغة العربية، وسيتم ترجمة المحتوى كذلك ورفع في وقت لاحق. مستر فيكي راي, the mic is yours.
Really appreciate the invite. I'm pretty excited to be here. But firstly, Assalamu alaikum to everyone. I'm really honored to be part of the Cyber Nights in Saudi Arabia. I know it's the month of Ramadan and everyone is dialing in late in the night, and great initiative, especially during the times we are now. We are all going online and sharing a lot of our work, and this is, I think, a great initiative and an opportunity for all of us, including the students, to learn from something like this. So really glad to be here. What I'll do is, so I'm just going to jump into my presentation now. Let me share my screen real quick. Today, I'm going to speak on basically introduction on threat intel and threat hunting. And very recently, I got to know about the Cyber Nights program, and I thought that this is a great opportunity for me to come and share some of the really important topics around threat hunting and threat intel. I know a lot of people in the cybersecurity industry are very interested to get into this field, especially the students who are dialing in, and you know, maybe some of you all are reading a lot of the research which we are publishing almost on a weekly basis. So we'll jump into some of the details in a few moments, but I really hope that the topics which we discuss, everyone takes those topics and digs in much more to see how they can explore and learn from that, right? Very quickly about myself, I'm a principal researcher in the Unit 42 team of Palo Alto Networks. I am based out of Singapore. I cover the Asia Pacific region, primarily focusing on cybercrime and nation-state cyber attacks. So my focus is primarily on this region, but we do a lot of collaborative work. Like we engage and we collaborate with law enforcement like Interpol and many other international law enforcement agencies. So not only do we research and publish stuff, we also kind of collaborate and see how we can help other organizations, maybe certs in different countries. So the main mission is to make cyber safer each and every day, right? So without further ado, let me go ahead with the presentation. The agenda today would be to understand some of the building blocks of threat hunting and threat intel, right? And when I talk about that, there are multiple open source frameworks, and it's not something which we have built, but these open source frameworks are I feel really essential to understand from a threat intel or hunting perspective. Whether you are a student or you are a seasoned cybersecurity guy, you need to understand these frameworks. We'll go through those frameworks, and then we'll talk about a bit on the tactical aspects of hunting. We'll cover some tools which we usually use. A lot of times we have our own favorites. It's not that these are the only tools which you should be using. There are hundreds of tools, but I'll be touching on some of the most common ones used not only by us, but many threat hunters or intelligence guys in the industry. And I was just told that I will have some more time to share with you all. So I added the data science part to it as well. So data science has been very, it's a very interesting subject to me. And while data science has been heavily used in within products to develop products, machine learning, applying machine learning algorithms and data science algorithms to solve cybersecurity problems, but from a threat hunting perspective, I think it would add a lot of value to see if we can solve our own intelligence work with that, right? So I'll share that at the end of the talk as well. So before our talk, a lot of times, people don't know what is the mission of Unit 42, right? And while I can just go by the textbook definition, which is already on our website, I enjoy using a different analogies, and this is one of the closest analogy which I've used for many years now. It's like cybersecurity or cyber incidents or cyber attacks is very complex. It's just like the Rubik's Cube on the screen, if you can see. And I'm not sure if you see right at the back, you will see I have a few Rubik's Cubes as well. So I love playing with Rubik's Cube, but what I'm trying to say here is, like the Rubik's Cube, it is complicated. It is complex. Cyber incidents or cyber attacks is also complex. To solve a Rubik's Cube, we need to connect all the same colored dots together. It's the same thing with cybersecurity, that we need to connect all the disparate data of some specific attack together, tying these cyber attributes of attacks together to understand or to extract patterns of complex attacks. Basically, from there's another way to look at it is when we watch movies, there are investigators putting on, kind of connecting different data points on a whiteboard. So for us, it's like, kind of, if there is a domain name, who was it registered by? Or if there is a malware, what kind of domain or IP address it calls out to. So all these, there's a very simple example, but these are essential parts which we are always trying to answer, like the who, why, how, and what in cyber attacks. Who did it? Why was it done? What was the motive? Was it money? Is it a cyber crime, or somebody was after intellectual property or some kind of sensitive data? So what is the motivation? What kind of tools the actor was using? So how can we answer it? It takes a lot of time. I wish we can solve like the robot here, which has just solved a 3x3 Rubik's Cube in less than 6 seconds. But cyber attacks takes long time to solve. But as I said, at the end of the talk, I've also added data science there, and we will try to see how we can solve or try to find patterns in a much faster way using data science. So again, let's go further. In the other analogy I'd really like to use is when we talk about threat hunters or threat intel guys, I use something like the superheroes. For me, I couldn't put the Avengers superhero poster here because likely that is, you know, Avengers basically, just for the copyright section. But if you have any of your superheroes, when we are talking about these movies, different characters have different powers. When all these different characters come together, they have a better chance to fight against the bad guys. It's the same with cyber also. Like, if everyone was only reversing malware, and it will be much more challenging. So let's say somebody is really good in reversing malware, another person is really good in pivoting off from data infrastructure analysis, somebody else may be good in linguistics, maybe there is a lure file with a different language. So when we have different when we have people with different skill set collaborate together, we have a better chance to fight against the bad guy, right? So anyways, I'm done with analogies now. Let's get into some of the details here. So when we are looking at cyber attacks, it's important to understand the pyramid of pain. I'm sure many of you on the call has already seen this multiple times, but just to put into context, it's important for us to understand what the pyramid of pain is. Right at the bottom, if you can see here, we have hash values, then the IP address. And as we go on top, we have TTPs right at the top, right? So in any kind of cyber attack, let's say if it is cyber crime or nation state or an APT attack, these actors, they can change, they usually do not reuse the same malware sample, right? So they would use different variants, so the hash values would keep on changing every time. So just looking at hash values is good for investigations, but it is very trivial. So likewise, the IP address and domain names can be reused, or the IP address can be reused, but they can be changed very easily from a threat actor's perspective. But what becomes very challenging for the attacker to change is their behavior. And this is where the TTPs comes in. TTPs is nothing but tactics, techniques, and procedures. These are basically behaviors, and I'll talk and I'll get into those in a bit more detail. But just keep this in mind that if we are able to understand the behavior of the bad guy, the tool set of the bad guy, because it is difficult for the threat actors to change their tool sets all the time. Yes, they change. Sometimes we have seen actors, sophisticated actors use a specific malware family for over years, or maybe a year or two. But once they have been exposed by researchers like us, maybe they try to make some changes or come up with a new malware family. But that doesn't happen regularly. So it's important to understand that if we can understand the behaviors and the tool sets, we have a better chance to track these campaigns. And some of the details which I'm going to share today is going to make things a bit more clear on what I mean by that. So the three main frameworks which I kind of preach all the time is the Lockheed Martin kill chain, the MITRE attack framework, and the diamond model. These are really essential for all, of course, I'm looking at it from a threat intel or threat hunting perspective. But if you are even doing red teaming or offensive security, this is equally important, right? When I'll give you some examples on that when we are talking about each of these frameworks. So let's talk about, before I get to that, I included John Lambert's tweet here, and don't think that, Vicky is saying that these are the only three. I just wanted to include, John's tweet as well. And John Lambert, if some of you don't know, he is a distinguished engineer, and he does a lot of cool, awesome research for Microsoft. And if you don't follow him on Twitter, I would say please follow him. He shares a bunch of good stuff. So anyway, so even John says, if you are into intrusion analysis, these are the three pivotal ones. But again, the context he was talking about from an intrusion analysis perspective, but I just wanted to add that this is equally important for, if anyone within the cyber industry, you need to understand this at least from a high level perspective if you're not getting into the nitty-gritties of it. But from an offensive research, it is absolutely essential, because when we are talking about attack framework these days, if you are doing offensive research or red teaming for some of your client or within internally in your organization, people are going to ask you, so can you emulate the attack techniques? And attack techniques, I'm talking about the MITRE attack techniques. So a lot of people whom I'm talking to these days, different organizations, different industries, whether it's financials, governments, and so on and so forth, the defenders or the cybersecurity head is going to ask or asks the red team people, the red team guys in terms of, can they emulate the same type of attack what the sophisticated attackers are doing? So because every defense every organization is currently now improving their defensive game, and they want to now defend not only against each and every cyber attack, but really understand who their adversaries are, and then defending and really prioritizing and focusing on that really changes the game for the good guys, right? So the first one, the kill chain. So I've been talking about kill chains for many years now, since this was released by Lockheed Martin. But you see, there are 7 steps in a cyber attack, right from the recon to maintaining control of the target, and it really kind of segments a cyber attack into 7 different steps, like recon, weaponize, deliver, exploit, take over, control, executing, and then maintaining control over the victim. But this is very high level. It is great. It's been really useful for me and many organizations who have been doing cybersecurity. But one of the things which it does not cover is, it does not focus on the nitty-gritties. It says, yeah, recon, weaponize. There are different ways to weaponize, whether you're using PowerShell or a macro or an exploit in a document file. It does not cover everything in detail in terms of the depth. It's great to have a high-level understanding of a cyber attack, or if you're a red team guy, how you need to approach. But to get into a bit more details, this is where MITRE attack was phenomenal, right? And when I talk about the attack framework, it is basically attack stands for adversarial tactics, techniques, and common knowledge. So what attack essentially is there are 2 fundamental concepts to understand on attack framework. Is the tactics, which is essentially the goal, the objective of the attacker. They use certain tactics to achieve its goal, right? And to achieve a goal, you need to have, basically, you need to execute certain techniques or use certain techniques to achieve that goal. So 2 simple things. Techniques are nothing but the specific actions which you will take to achieve your goal, which is a tactic. And the next slide, which will clarify this a bit more if this is not clear, if this is not much clear already, right? So again, from a cyber attack perspective, there is an adversary group, there is an attacker, and they need to, they have a goal in mind. Let's say they want to steal your credentials, or they want to exfiltrate data from the target machine. So that is a specific goal they want to achieve. So how do they do that? And as I said, there is tactics and there is techniques. So tactics is basically the goal, and the adversary group usually uses a technique to achieve that tactic, right? And how do they do that? They use a specific software to execute that technique. So what I mean by that is when we are talking about software, it is essentially malware from our perspective, right? So an adversary group uses a software which is going to implement that technique to achieve that goal. So again, this slide will make it a bit more easier. I have a lot of examples here, and I think these graphical representations make things much more easier to understand the concepts. So here, Ocean Lotus is a threat actor group, very active in the Asia Pacific region, but it has expanded its operations globally. So I'm just going to give a very quick example. I'm not going to say that this is the technique they use, but just to illustrate our concept here. So let's say there's a group called Ocean Lotus, and they want to have access to the credentials. How are they going to do it? They are going to um, um, implement, or they are going to use the Mimikatz tool. Mimikatz is used for dumping credentials off memory. So they are going to use Mimikatz to dump the credentials and then have access to the credentials. So that's how you meet your objectives. So very, very, very simple here. So I hope, like, for you to have much more understanding, you should go to MITRE's website, and they have really documented things very well. A lot of things which we publish eventually gets to their website. They have referenced a lot of our work. But yeah, they really have an exhaustive resource of a lot of knowledge base, like, about Ocean Lotus, what are the different techniques they are using. So we are not going to cover all of that here, but this is an introduction for you to do your further research and learning from this. So as I said, from a high-level perspective, tactics, there are currently 12 enterprise tactics, and within every tactic, for example, here I've highlighted only the exfiltration techniques. So exfiltration on the left-hand side, if you see, is one of the tactics, which is used by a threat actor, and there are 9 unique techniques within that specific tactic. So these are well documented, and to understand your adversary, you really need to understand what kind of exfiltration techniques they use, who they are. If from a Saudi Arabia perspective, there is a group called the oil rig threat actor group, and they have been targeting a lot of organizations in the Middle East and Saudi Arabia as well. So definitely look it up. We have published a lot on oil rig, and you can again refer to what are the different techniques they use, what are the tool sets they are using. So please spend some time with the attack framework. This is going to be very, very useful in your work, whether you're doing offensive or defensive research. So this is just a screenshot of the enterprise matrix, but now they've also published pre-attack, that is mostly recon stage and before getting access, before exploiting a target system. So different steps and all the tactics are mentioned there. So please spend some time going through all the techniques as well as tactics which have been published. These are awesome. What we have also done is we have, so if you go to unit42.github.io, or just go to unit42.paloaltonetworks.com, you'll get you can then go to the playbook viewer. This is the playbook viewer. We have documented a lot of threat actors here. I couldn't just include all of that on this screenshot, but we have over 21 threat actors published already. I think it's the list is more now. But this, what we are doing with the playbook viewer is, you can see here, I've just highlighted oil rig. which is the threat actor group, very active in the Middle East region, especially, a lot of targeting in Saudi Arabia. So you got to understand this actor, what is their motivations, and what kind of behaviors they commonly exhibit, or what are the tool sets they typically use to better understand. And I'm not going to limit or say just focus on oil rig. You have to understand all different threat actors, but it is really good to understand how different threat actors operate, what are their commonalities. And when you're looking at from a defensive posture, when you are looking at let's say you are reviewing cybersecurity products, you got to answer or ask the right questions to the vendors like us, that, okay, I understand that these are the threat actors, this is how they operate. Can your product defend against this type of attack, right? So these are the questions. It's you can use the attack techniques and the attack framework in so many different ways. Even if you are an architect, or deploying these security products, you have to understand this and then ask the right questions. That way you are going to benefit majorly from whatever you are doing or whatever field you are in, right? So again, let's get into our field of work now. Um, so from a oil rig perspective, what we are doing with the playbook viewer is whenever they are changing their place, what I mean by place is they change their tool sets, or they are changing their tactics over a period of time, we are updating that on the playbook viewer. So you can see here oil rig from May 2016 to August 2017, they were using similar techniques and tactics, and then again 2017 July to August they changed a bit. So whenever they have made those changes, we have kind of included that. And if you see here on our playbook viewer, we are actually we are reflecting or using the kill chain here, but as soon as you kind of click on each specific indicator, you can see you can download the specific um, you know details over sticks 2.0 format. But again, um, you can see the similarities on how we are trying to map attack with playbook viewer when we are going through the details on it. So please, spend some time with the playbook viewer when you have some time. But I just wanted to give you an example of how we are kind of using the attack framework in our field of work and how you can use it as well. The other thing which I wanted to also mention is the playbook viewer is open source, and if you want to track your own threat actors, feel free to download the tool and track your actors based on that. So just because Unit 42 have published, I'm not going to say that just follow only that. You build on to your own playbooks, right? And many other security firms has actually taken, if you see, I wouldn't name those specific firms, good friends, and they have basically used the playbook viewer and are using that tool to track their own campaign. So it's been very beneficial for the wider community. Okay, so let's go ahead. The third one which I wanted to talk about is the diamond model. It is one of the simplest, and it can be very complicated as well. So that is a really good white paper. So highly encourage you to read the white paper, but we are going to talk about the diamond model on a very high level. It is very simple, but whenever you're looking at cyber attacks, if you're an incident responder or even a threat intel guy or a threat hunter, you should always visualize these cyber attacks and then try to map the diamond model to these specific attacks, right? So what is the diamond model? It is a mapping of this cyber attack on a high level, but it gets into really a lot of the details and on each and every step of the kill chain as well. So in a cyber attack, there is the victim, and of course there is an adversary, the attacker, and the victim is targeted using a capability of the adversary, which is in the form of malware or specific tools. And the capability, the adversary is basically communicating, or those tools is communicating back to the adversary using an infrastructure. So in the form of C2, which is basically owned or controlled by the adversary. So basically this is how the flow looks like, that the victim is basically infected with the malware. That malware communicates back to a C2, which is controlled by the adversary. So now the C2, once you understand this, or once you, let's say you are investigating a cyber attack, you understand the C2, or you figure out that this beacon to a certain IP or domain is malicious. So once you start searching on using only that particular IP or domain, you may find more victims. So that is why I have an arrow from C2 to the victim, because that way we have found a lot of victims. We always find new victims just by identifying a new unique C2 which we may have not known about earlier, right? It's the same thing. Once we are kind of understand a specific malware or some unique malware family to a certain threat actor, we know that okay, this unique malware is only being used by a specific threat actor. So I'm going to give an example in the next one. So here again, I'm going to use Ocean Lotus, but if your favorite group is oil rig it is. So typically victims are targeted if they are, they can be targeted in many different ways, but spear phishing is one of the most common ones. Victim gets an email, victim clicks on that attachment or a link, there's a malware dropped, and the malware connects back to a domain name or an IP address, which is controlled by the Ocean Lotus group. And if you can see here, okay, I'll click back again, that Curdown, I've added the malware family. I mentioned Curdown. So I'm going to give some examples later in this talk. So Curdown is a new malware family, which I actually published last year. It's not new anymore. It's been used for a long time now. I would say from 2018. But when I published the blog, it was about a year old, which was unknown. Nobody had known about this malware family. It is a downloader malware family. A lot of focus in our industry is on the Trojan or the end payload. But a lot of times these downloaders, if it is unique, it gives us a lot of interesting information about the threat actor. And I'm going to share all of that in today's session. Right, there's the same thing which I mentioned. So when we are talking about threat intel, I quickly wanted to cover, of course, there are three main pillars. Like if you have taken a science threat intel course or many other, threat hunting or threat intel course, this is typically discussed like what are the type of threat intel, that is strategic, tactical, and operational intel. I'm not going to give definitions on it. There is, if you're interested, there are tons of stuff which is already published. And again, today's session, we can't really cover all the different types of intelligence, but I'll just briefly mention what these three different ones are, right? Like when we are talking about strategic intelligence, and as a threat hunter or a threat intel guy, especially working for a cybersecurity vendor, we need to be very clear that we shouldn't look at intel from I shouldn't say that from a strategic perspective, but a lot of times when we are talking or having discussions from a strategic intelligence perspective, there is a bit of bias. Like what I mean by that is, let's say I'm based out of a certain country or a region, and I may only focus, like if a specific threat actor. So when I'm talking about oil rig, let's say, I give an example of oil rig or ocean lotus. If I'm only thinking about, we just found a cyber attack, or there is an attack going on. It could be ocean lotus, or it could be oil rig. So if you always start your investigation by already painting a picture, or already maybe assuming that it could be a certain threat actor, then there is a bias there, right? Because you may make mistakes. So what we always try to tell anybody doing intelligence or hunting work is always stick to tactical and operational intelligence. When you are sticking to the technical facts, eventually you are able to make the right determination, right? Because you shouldn't look at a certain attack and already have any types of bias, because the moment there is a certain bias, you are bound to make mistakes. So keep that in mind. There is a whole lot of other discussions, of course, from a strategy perspective, could be from an end user perspective, could be what you need to look at, what is your what should be your strategy in terms of prioritizing who your threat actors. You should do that. I'm not saying don't do strategic intelligence at all. I'm just trying to say that don't get your analytical bias make certain decisions. Your decisions should be made based on tactical and operational intelligence, which you are extracting from your investigations, right? So in this talk, of course, again, I don't have enough time to get into the operational intelligence. Operational intel covers like how you are extracting data, what kind of tools you have, what you have built, what kind of automation you have in place, a lot of other things. So I'll with the limited time we have today, I'll spend a bit more time on the tactical part of it, like what kind of tools we can use for hunting. It gets a bit more interesting, but definitely spend some time understanding what these three types of intelligence are. So as I said, we are going to focus in the next couple of slides. The second half of this talk will be mostly on the tactical aspects. The number one tool which which we can't not mention is Yara. Yara is an amazing hunting tool, and this is by far probably one of my favorite. I have many other favorites as well, but Yara is being used by almost all serious security vendors or serious security research team. I mean, if somebody is not using Yara, I would say, they definitely need to take advantage of the powers of Yara. So we are going to cover Yara on a high level. I understand that there are lots of people from varied backgrounds. We won't go in depth. Yara probably is a separate presentation by itself. There are an hour-long presentations. There are 3 days or 4 days workshops also only on Yara. So Yara is amazing. It can be very simple, but it can be very complex as well. So it is all up to the user how you can make advantage of this awesome tool. It's again free and open source, and we are going to look at some examples now. So this is how a Yara rule looks like. It's just like creating a signature, for IDS signatures and open source signature, which everyone knows is Snort probably. If you have not used Snort, like I've been using Snort or for a long period of time, right? Now Snort has evolved to many other different type of IDS tools like Suricata, but this is how a Yara rule looks like. And again, what Snort is for the network analysis, or finding patterns or creating signatures for network data or IDS, or basically the packet data. Yara is for basically files on typical binaries. So Yara you can write very simple or very complex signatures to find binaries on a system or a server or wherever they are. So let me go through a simple Yara signature which I've written for this talk. So right at the top, the first line, it says rule Yara introduction. So you've got to give the name of that signature, which is the Yara signature name is Yara introduction. And within the codes, there are 3 important sections there. There is the meta section, strings, and conditions, right? So a good Yara rule should have metadata, like who was it authored by, what is a small description for the signature, and if there is a reference, for example, it could be a malware hash, it could be a link like I've mentioned here, it could be it could be some reference to whatever this particular malware or this particular rule has been written for. So we'll get to the details in the next slide. But the next section is strings. So let's say this rule will hit if the string cyber nights, with this variable. So we are giving the string to variable A, B, and C. So cyber nights, if it hits cyber nights, again, this string or this string, and the condition I've used is either of this, right? If you need all, then you can mention condition all of the above, or whatever the signature format is. You can give all here, or here, if any of these 3 signatures, these 3 strings match, my rule will trigger. And I'm going to illustrate this with a demo, which will make it clear. So to give a demo, which I think I really like using real world examples. So this is a blog which I published back in 2016 on Orcus. Orcus is a rat. Basically, it's a remote access Trojan. And a couple of cyber criminals, they started selling this rat in underground forums. And as soon as this rat was being sold in the underground forum, back in 2016, in the month of April, it was being sold. And we immediately saw the same rat being used to target our customers. So what I'm going to do is very quickly, I'll switch to, since we have some time, I just will give you a very high level overview of the blog. So I'm going to switch my screen to my browser here. So hopefully you all can see my browser, and let me make it a bit more bigger so everyone can see it clearly. So this is the blog which I published, and I actually talk about, there is this guy called Sources who published, who posted, who basically posted a post on an underground forum selling this tool, right? So you should give it a read, but a lot of times these blogs have a lot of details. Like I've mentioned how this rat actually works. It was very interesting to see the details. What are the unique features? Very typical features are there of a keylogger or a rat, but they really had some advanced plugin system and so on and so forth, right? So very unique. And we published this story. And I would like to highlight also that before publishing, I think many of you would know, and I've actually mentioned it in the blog here, that Brian Krebs actually kind of published a similar story just a few weeks before we published it, saying that a Canadian man was behind it. But in fact, our publication says that there were two main guys behind it. One was a Canadian, and another is Sources, who, according to our research, was likely based out of Germany. But you should see it, and there are also a lot of reports out there in the public domain which says, with more details on the threat actors were actually actioned on by law enforcement in both the countries. So definitely look for that, or Google on the Orcus story. Anyway, so just getting back to it. So once we publish this kind of research, we keep a track on these kind of malwares, right? So to make it very simple, I'm going to show you how we can use Yara to kind of understand a piece of malware and then write a signature for this. So let's say once we have analyzed Orcus, let me go to my terminal now. So I have, let me see what all I've prepared for you all. So I have a folder called as samples, and you can see here, just to illustrate how Yara works, I have about 30 different malware, hashes. But not only hashes, but these are basically samples of a certain malware. And there are Orcus malware variants in this in the 30 odd malware sample, right? So I'm going to show you what my Orcus signature looks like. So let me just quickly go back to my slide, and this is how the Orcus, basically a very simple form of the Orcus Yara rule which I've created. So you can see here I've given the name to the rule as rat Orcus, and then I've ensured that there are meta sections or the details with metadata on the rule. Let's say author, this is my handle, this is my Twitter handle, 0xvk. Date, this is not the real date. I've just used a dummy date here just for the example, and description is Orcus malware family. I gave 3 unique hashes which I used to create this this rule. But again, when I was looking at it, I thought, okay, these 3 samples and the what I extracted, the unique attributes of these samples would be helpful for me to track other new variants. So here you see the strings which I found was unique to these samples was orcus.commands, orcus.installation prompt form dot orcus.property. So all of these unique ones, and full word ASCII, these are these are some different descriptors or features of Yara, which is going to reduce your false positive rates, right? So it's all documented well on Yara's documentation. So give that a read. What do you mean by full word? How does it help? If you don't use full word, what kind of results you get? So play around with it, right? But I've used this, and let's see. And the condition I've used is 6 of them. Actually, even if I use 4, I've got positive results. So let me go back to the terminal and run the Yara rule, right? So before that, let me see how many samples do we have. So we have 30 samples, just to confirm. We have 30 samples in this samples folder. Let me go back. I'm going to run, or basically run the Yara signature which I've created. So let me confirm what the Yara signature looks like for Orcus. And Yara signatures have .yar or .yar extension. So here is the same signature, just to double confirm that we are looking at the same signature, and we are going to run the same signature as I've showed in the slide. So let me go back. So how do I run? The command I'm going to use is Yara. Then I'm going to provide my signature, and then I'm going to use the -r flag and give the sample. So -r is for recursive. Given I'm giving it a folder, it will scan the folder recursively. So let's see what I get here. Wow. Okay. So as you can see, it is so powerful that as soon as I ran that, it didn't take too long to really scan and hit one by one. A lot of times, if you have used many different tools, it may take some time. So of course, if the sample set, the folder had only 30 samples, but let's say you have terabytes of data, sometimes it would take time. And you would usually run on an SSD if the data or sample size is that big. But again, here I've got certain hits, and I don't know how many hits. So let me see how I can do that. Let me pipe it with this and see how many hits of the signature I created. So I get 24. So I've already tested it. All 24 samples were the 24 samples which I've extracted and known Orcus families, just to ensure that this rule works. And I've added 6 different malware families to my samples pool just to mix it up and see if anything goes wrong. But as you can see here, just a string-based signature was very useful here. Again, this is I'm just giving you an example to illustrate how effective a simple Yara rule can be. But again, Yara rule can you can write very complex Yara rules using hex values and so on. So again, when a lot of us, when we publish blogs, many times we have actually included Yara rules, so it's going to be useful. I hope this was kind of clear, but let me just zoom in again, just so you know, see what the commands look like and the responses. So hopefully this is much more clear. Okay, so very this was a quick Yara example, so I'm done with this. Let me go back to my to the slides. Okay, so we are done with Yara. We are done with the demo, and the other thing which I wanted to highlight was I mentioned Suricata IPS. Again, it's nothing but very similar to Snort, but Suricata revamped version of Snort, if I can say. There are lots of features which have been added, and many people say that yeah, Suricata rules, but essentially the rule sets are very similar to Snort. But Suricata, it's a GUI. When Snort was released, there was no GUI. Suricata is actually has a graphical user interface and is well supported. So, anyways, very recently, we published a blog. So we published a blog on specific COVID-19 campaigns. As you know, I'm sure that many of you on the call would have seen reports on cyber attacks utilizing COVID-19 lures or COVID-19 themed cyber attacks, right? And we have been tracking a lot of these campaigns, and we have been publishing many different unique blogs around how cyber criminals and sophisticated threat actors are kind of taking advantage of the pandemic to target their victims. In one of the blog, if you know, the link is already here. I will be sharing these slides with the team, with Muhammad and the rest of the team in Saudi Arabia. So I'm sure you will get access to all these, what I'm discussing, on like the links and all, in case you are you're not able to take note of. So in that blog, we have also kind of shared how these different campaigns are being executed by these criminals. And here in this case, there was a campaign where a unique email, shipping@liquidroom.com, was used to send phishing emails to multiple different victims, and some of them are actually from governments and also the healthcare. And all of these malware families were the same keylogger, which is very easily found in underground forums. So anyways, that's not the point. The point is, once we analyze all this information, we also see that a lot of times these malwares actually call out to a specific unique IP address. So when we look at these network traffic, I've kind of masked out some of the credentials. It actually, the malware has hard-coded credentials. So sometimes we are able to understand how they are exfiltrating the data. So in this case, if the victim is compromised, the username password of the command and control is hard-coded within the malware, and it will steal all the data and send all the data or the stolen data to the command and control. Once we identify or understand some of this network data, we can now create signatures in the form of Snort or Suricata to detect this kind of network traffic. And this is again a simple Snort signature, again, for illustrating our context here. But again, it doesn't mean that every time you need to have a complicated signature. Simple signatures like this do the job very well, and it is less resource intensive. So anyway, so what this means is, what I'm telling Suricata is alert, or as soon as you see similar patterns, and we'll talk about what the contents are. I've written a rule which tells the IDS, if you see these contents, send me an alert. So alert, let's say TCP HomeNet, that is your home network. And if it is going out to any, that means any IP address, any domain, and any port, or any port, right? So you can be very specific here, maybe specific IP address. Of course, you don't want to be specific because they can steal this pattern to any other C2. As I mentioned right at the beginning of my talk, the pyramid of pain, domain names, IP addresses, they keep on changing. So here I've given the signature name as Agent Tesla exfil. That means when I get an alert, this will be given. Let's say you have a central database or a console monitoring all your IDS logs, right? So this will pop up, Agent Tesla XFIL. And the contents it is going to look at is OS full name, username, content, password. It's very simple, and then application. So if all of this match, then trigger this rule. And I've also given a reference URL. That means this is referring to our blog which we have published. So every time it is very important that whenever we write any type of signature, there is a reference. So somebody who sees the signature immediately can go back and see why and how this was made, what kind of data was used to create this signature, right? So I've tested it out and it works pretty effectively. A very simple rule here. Okay, so okay, enough of the IDS part, but I also wanted to quickly mention that if you're quite interested on traffic analysis, and as a threat hunter or an intel guy, you have to have a good understanding of packet capture data, or how you look at network traffic, or how you can read packet captures, right? So no better resource in the public domain than malware traffic analysis. And I mention it in many of my talks that the guy behind malware traffic analysis is actually a Unit 42 researcher. He has been a Unit 42 researcher for many years now, and he has been maintaining malware traffic analysis, well, much more before he joined us. So he still maintains it very actively. A lot of free content is there. You can download packet captures, you can read his blogs, and a lot of amazing content is there. So if you want to play around with it, definitely go there, download all these packet captures, all these malicious packet captures, see if you write your own rules and play with it if it hits or not. And if you have any questions, feel free to reach out to Malware Traffic or me. And I'm going to say that a lot of people in the industry who are actually using machine learning to write certain algorithms to detect network traffic are actually also using packet captures, which is being published in the malware traffic analysis.net site. So play with all the stuff which is available to you. Quickly, the other part which I wanted to also cover is, when we are talking about threat hunting and threat analysis, visualization is huge, and a lot of blogs which we publish has certain visualization to make to illustrate all these different complex data sets, or to illustrate the connections of these data sets easier on our on the research blogs or white papers which we have published. So what are these how are we kind of generating this? This is using a tool which is Multigo. It's a commercial tool where, I mean, not only being used by us but many other different cybersecurity industry, but they also have a community version. Play with it, it's amazing. So this is also one of my favorite tools because it does reduce a lot of my manual work, or it also helps to visualize a lot of this data which I'm kind of mining and connecting to. As I was saying again, like this is like how shall I put it? This is like a whiteboard for us to connect and understand all these disparate data sets which we are kind of tracking. It's just like these investigators you see in movies where they're connecting lines or with threads of one data to some other data, or a bad guy. We have done that using Multigo. This is another example. This was this of course this is a very zoomed out version of a graph. I'll give you some more examples, but what this graph says is, you can see here, this is there is PV. There's what PV is. PV is a poison ivy backdoor Trojan. Yahoya is another backdoor. PC share is another backdoor. So what we were looking at is, we were looking at Tropic Troopers campaigns, and this basically says that they were using multiple different malware families or Trojans to target their victims, but there were common infrastructures used. So we were able to pivot off from one infrastructure to the other, and now we have a better understanding. This is very important for intelligence guys, is that just to understand the capability of the adversary you are tracking, right? What kind of tool sets they have, how long have they been using a specific tool, and what infrastructures they have. So we do this a lot. So if you really want to do investigative work, uh, some visualization helps a lot. And this is, again, of course, even I, just looking at this graph, this is a PK plug Multigo chart. But this is, again, a very zoomed out version of multiple different campaigns over a long period of time. But just this is just to show that how vast their operations have been. So this group have been very active for a number of years. But let's look at how, a bit more, in a zoomed in fashion. This is another blog which we published. The Mole Rats delivers Spark backdoor. And so what this Multigo chart shows here, if you see right at the bottom, multiple different malware samples were calling out to this particular domain. And we were able to create a Yara rule using these two different samples. So we found that these two, you can see here, I'm not sure if it is big enough, but what this is Yara detection. That means these two samples hit a specific Yara rule. These two samples were used to create a Yara rule. And when we ran that Yara rule, it eventually hit many other samples in our database. And those samples were calling out to a different domain. So you see how effective this was. We were able to write a Yara rule from separate samples, and that Yara rule was effective to find other sample sets. So this is how we are able to pivot off from one data to the other. And on the right-hand side, this is a query. We have a tool called as autofocus. This is our own proprietary or commercial tool which we have. This is, again, a hunting tool, a threat intel tool, and autofocus was used for, and this is an autofocus query which was used to find more different samples. So this is great to see how Multigo can be used with different data sets and understand these disparate data sets and these connections together. So we, at least I personally, use it extensively during my research. So play with the Multigo tool. Right at the end of the talk, I'll have a slide which will include all the different links or references to these tool sets. So download the community tool, understand how Multigo works, what are transforms, can you create these transform servers? That's amazing, like from a GUI perspective, right? Okay, so the other thing which I mentioned was, how we can use data science. Let me see how much time we have. Well, of course, we have crossed over an hour, but I have a bunch of things very interesting which is related to data science. So let's continue with this. Well, I think I need some water now. So as I've been doing my research, and I've been looking at many other ways to see that how can we kind of up our hunting or threat intel game in terms of how can we make our life easier, because a lot of times, as I was saying, tracking cyber attacks can be very complicated, can be very tough sometimes, right? And are there tools which we can leverage to solve our challenges? Because there are lots of challenges we have day in and day out, and there are already lots of tools which is being developed by not only the cybersecurity industry. Like, for example, the data science community in general have been, there are multiple tools which are used to solve different challenges globally. So I'm not saying that I'm the first one to figure this out, or I'm the first one to use this technique, but a lot of people have been looking at using Jupyter notebooks or Jupyter Lab to find interesting patterns in data sets. And it's being used by all data scientists majorly. A lot of data scientists have been using Jupyter notebooks for a long period of time, but a lot of cybersecurity intelligence or hunters are now exploring Jupyter Lab or Jupyter notebooks, right? So I've started exploring that, and trust me, it has given me some amazing results, and I'm going to share all that in a bit. So some of the major libraries which I've used and which have been very useful is Matplotlib, plotting all these, whatever you are kind of looking for, you can plot that graphically using Matplotlib. Then Pandas, NumPy, these are all basically used to slice and dice your data. And of course, Jupyter notebooks or Jupyter Lab, which makes all this easier in a single pane of glass. And let's play, or let's do a live demo. So again, it's going to make it easier to understand the concept, right? So I've created something for you guys. In fact, I gave, this was the GitHub page, but I've actually, let me see. Yeah, there you go. That's the tab. So in fact, I've given, I gave data science talk or at RSA in San Francisco earlier this year in Feb, just before all the craziness on the pandemic outbreak. It was going on in other parts of the world, but we were fortunate that RSA happened. And I gave a talk on how we can do some magic using data science, right? And I'll share all of that with you guys. But this is the same example which I used at RSA. So what is typically the most common threat intel tool everyone has? Well, it is nothing but Excel. Again, of course, we have a lot of tools, but I have a Excel here, Excel file, which is the malware list Ocean Lotus here. I've just loaded it. So if I just double click it, it will open up here, right? So what I have in this Excel file is I have a column which tells me all the timestamps of the malwares when we saw it, the malware hash in the format of SHA-256, what is the malware file type, file size, and also we track the specific malware families. So all that, when I mentioned that what tool one of the most common ones which we have internally is autofocus. So I've actually generated this Excel sheet using autofocus. And again, I'm not saying that you need autofocus for this, but any tool which you are using to generate a raw Excel file, maybe a raw file, can be used here. Or let's say you're manually recording all these attack data, but once you have hundreds and thousands of lines of just documentation on Excel, you have to go and create charts manually. It becomes very difficult. But using Jupyter Lab, it can be very easy to find many unique patterns, right? So what I've done is, of course, I've loaded this up and I've written some specific code. So in Jupyter Lab, it can be used in many different ways. I mean, I'm not going to say that this is the only way, but on a high level, you can load many different. You can even have a terminal here. You can run programs or commands from Jupyter Lab console. But here you can see this is how my kind of Excel sheet format looks like. Different, this is basically all the artifacts of the Ocean Lotus group which I have. Now, what you can also do is, well, this is the main part, is you can write simple Python programs to extract unique patterns from all these data sets, right? Um, so here what I've done is, I'm not going to go through the entire code, but one really good part of this is you can actually share your intelligence work, and once you save all of this, this can be shared with some other people within the team, right? And you can also comment out your code. I've said that the results from the below code gives understanding of the file types being used by a certain threat actor, like, I've mentioned Ocean Lotus, blah blah blah. And you can see here, this is these are the unique I mean, this is the very simple script I've written. So basically what I'm doing here is I'm using pandas and matplotlib and seaborn. And I'm not going to go through each and every line. It's very simple. I'm just giving the mal variable this particular file, and I'm just plotting specific columns and the numbers of this particular file. So very quickly, once I've written this, what I'm going to do is I'm going to execute this here, and the results also I'm going to have it here. So it's going to be very useful because it's in the same place. It's not like before Jupyter Labs, I was running this separately in the console, and it would generate this PNG file, and I have to open it separately and see it. But with Jupyter Labs, I can just write my code, make modifications, and then get my results. So even if it is just 4 or 5 lines of code, the main line, I mean, this is just plotting. You're just plotting this all 4 is just plotting on the XY axis, and just giving a title and then saving this file. But the main thing is just this. These are the 2 main piece of code which you have written to get this information, right? And this is very important because from a defender perspective, and again, I'm just going back from to my earlier discussion, is that we need to understand the behavior, or we need to understand the capability of the adversary we are dealing with. So when we are looking at Ocean Lotus, and I could have easily done this for oil rig, but with the limited time I had, I already had this data for Ocean Lotus, so I'm giving this example. So you can see here the main file type or malware file type of choice has been PE and DLLs. It's not a surprise because most threat actors, they actually create, of course, not a surprise that Windows is the most common operating system being used at large organizations, and also in the the commercial sector. So, but you can see here, this also gives us an understanding that they have used word-based malwares, RAR archives, RTFs, DLL 64 bits, DLLs, and even Mac OS X. So if an actor is actually creating, a lot of people think that there are no malwares created from, if they have Mac, that means they are secure because there are no viruses or malwares for Mac. But well, as many of us know, there are actually, of course, the numbers are lower, but if they are actually creating Mac-based malwares, they have put in a lot of effort, and these could be much more targeted in nature, right? So the other example which I have, again, all of this is the same single file. This is the same single file, but I'm going to get very unique patterns out of it. Here I'm extracting what are the file types. The next one, let me see what I get, and then I'll just discuss the code. So now again, I'm always interested with file types, but the other thing I'm also interested is what are the different unique malware families, and how often do they use these malware families, or what is their favorite malware family of choice. So you can see here, Dennis, Pokerface, Ocean Lotus, OS X, Cobalt Strike, Bad Cake, Windshield, Curdown. So Curdown is right at the top. This is the malware family. And again, guys, I've not created or faked this number just because I was the one to find this Curdown malware family. But as you see, since 2018, they have been extensively using Curdown. And these numbers are actually a bit older. It's a couple of months old already. The numbers are much, much higher now, right? So bad cake has been used for a few years, windshield as well, but as I will show you the timeline in a bit. But Cobalt Strike is absolutely being used quite extensively, and Cobalt Strike is actually being delivered and is the end payload many times. So cut down, as I said earlier, this is a downloader, and eventually it actually drops. Most of the times we have seen that they drop the Cobalt Strike. And if you're an offensive researcher, of course, there are legitimate uses of Cobalt Strike by red teaming guys, red teams when they're doing their penetration testing activities. And I understand um, from the team in Saudi Arabia, and Mohammed was telling me earlier that you know the previous days a lot of people spoke about pen testing, doing red teaming exercises there. So it's good to know that, but it's also interesting to see how similar tools are also being leveraged by nation state APT threat actors. So again, very few lines of code. I've just used the same, in this case, actually, I've used tags only. That is a different different CSV file, which I have only for this particular for the tags, for generating this tags. In fact, as you see, I have in this particular CSV file, I had tags, so it would have worked either ways. I just had to give the specific column number on this. So the last one, and this is one of my favorite. Again, these are just giving the specific malware families I'm looking at for, and this again the same CSV file, and basically I'm just extracting or parsing out this timestamp information from this particular CSV file. So, and I'm looking for these particular malware families. So let me run this and see what do we get. So I'm executing this, and then you see in a matter of seconds now, I have an understanding of how often or since when this specific APT group has been using these malware families. So you see here, Windshield, they have been using this at least as far as I was able to see, that 2014. Some reports say that they have been using Windshield since 2012, but I was able to confirm at least until 2014. You can see Ocean Lotus OSX, they have been targeting not in a very large scale basis, but on a very targeted basis. The numbers are lower as compared to other families, but they are still being used since 2017, and it's still active. So bad cake has been quite regularly used until last year. We have seen the numbers gone much lower, but I would say that Cobalt Strike and Curdown is in conjunction. If you can see here, Curdown we have been seeing, and there is a big cluster here, right? Since 2018 it started, and the cluster has gone higher. Again, as I said, these numbers are a bit older. It's actually gone past like 2019, then 2020, and it's still being used. So and if you see here, there's a big cluster of Cobalt Strike as well. So these two are in conjunction with each other. So just to give you an example, this would have typically taken me a long time, but because I already had a raw data file and I just used Jupyter Lab, I was able to extract this very fast. It would have taken me absolutely a long time to extract this data. And even on our blog, when we published this, I actually have this open here. We published it earlier last year, and you can see here in this blog, we really go into the details in terms of how we found the exploit doc. This specific group actually had two different DLLs in the document file embedded, basically copy pasted base64 encoded and copy pasted the entire payload on on the document. Again, I won't get into the details, but give it a read if you are curious on how we investigated this campaign. Two different DLLs. One was for 32-bit and 64-bit. So the macro would check if a victim's machine is running 32-bit, drop the left DLL. If it is running 64-bit, drop the right payload. So basically, this was, once you enlarge the font, you can see the entire payload. It was very simple but effective. This was the macro logic of to decode the DLL. And this was the this decoder is already available. The decoder which was embedded within the macro. Again, so I use certain data science concepts on clustering, and I'll talk about it. I have another slide which we will discuss this in detail on how I was able to use certain algorithms to find this cluster. It was amazing to do this. But what I wanted to share, I'll talk about all this also in detail, but yeah, we will discuss the entire thing in a bit more detail. But I just wanted to share that this was a fun report to work on, because a lot of data science concepts was used in this particular research. Okay, let me go back to my slide. So we are done with the demo, and okay, these are the links which I had created for you all. Okay, this is not the end of the talk. This is just the end of this presentation. But I wanted to highlight again, like, of course, it may be challenging to take your questions right now. I'll try my best to respond, but if you have any specific questions, always feel free to reach me on Twitter. That's my Twitter handle. That's not an O, that is a 0xVK. So if you have any questions on all the things which we are discussing, feel free to reach out to me on Twitter. So let me just quickly stop this share, and I'll open up another I hope you all can see my screen now. Okay, so talking about data science, it is exciting. So I'm not going to give you a textbook definition of what data science is. Um, so data science to me is it's like magic. Like all the data scientists out there, they are magicians to me. And because what I was able to do and what I see these data scientists are able to do with large data sets, I call them the magicians, right? So a lot of times the analogy I've used here is in these large complex data sets, a lot of interesting things are hidden. Sometimes it is not visible to us. And as you see in this, there's a hidden dog within underneath um, another dog. So there are hidden, interesting hidden patterns which can be extracted using data science. And as I said, the data science are magicians. A lot of times, we may spend hours analyzing things manually, but sometimes if you use data science concepts, you can spend some time eating your favorite snack. As you can see, this is one of the data scientists running its program running its program and enjoying a pizza. Anyways, enough of the analogies. I just wanted to again give you all a clarification. I'm not a data scientist, but I'm trying to just solve my challenges using data science, right? So one of the common challenges, researchers, malware researchers or threat hunters, intelligence researchers, many intelligence researchers may, they may only be doing operational intelligence, maybe not doing malware analysis, but a lot of us do malware analysis, malware reversers. And one of the major, challenges is when we are looking at new malware families, um, it is difficult. It gets challenging to first, kind of make a determination that, oh, I found a new malware hash. So the first thing to know is it a variant of a known malware, or is this hash something new? So a lot of times we already have our automated systems built, and the first thing to do is check our database, check our records, check our knowledge base. So if we know about this malware family, it can be a different hash. It doesn't have to be a same hash. I mean, nobody looks at hash based, nobody determines malware families based on hashes anymore, right? There are many other ways to understand a malware family. So, but the first thing to look at is, do we know about it? So if we know about it, uh, um, the next step is which malware family it is. A lot of times we don't, it may be a unique malware family, or the other way which has been used to find or perform some similarities is SSD fuzzy hash. I won't get into the details of what is SSD hash or what SSD fuzzy hash is. Please look it up and spend some time understanding how SSD works. Again, I'm not saying that SSD is not effective. It has been effective, but I think all these different ways is still very challenging. So I'm going to give you a very good example here. Is you can see here, this is from I've taken a snapshot from our autofocus system, and you can see here the verdict of these two malwares are given as, yes, these are malicious, two different MD5 hashes. I typically use SHA-256, but because to fit all of this in this, I'm just using MD5. You see unique file size, that's okay. Different malwares, of course, have varying sizes. You can see import table hash. Import table has been very effective. I've been using import tables to track many different malware families. But again, you can see here completely different import tables, import table hash, right? So again, I don't want to get into the details of what is an import table hash. Please, if you're not familiar with it, no problem. Just look it up. It's very simple to understand what is an import table hash, what it hashes, and basically its functions within a malware family, imports of a certain malware, right? So, but again, when we are looking at similarities, import table hashes can miss because this is completely two different hashes. SSDeep also can miss because again, this is a completely different SSDeep hash for two different malware samples. But when we looked at in our sample, in our database, both of these samples were calling out to a single domain. And when I was doing my analysis, it looked very similar. And this is the Curdown malware family, by the way. And now, once we have an understanding of the malware, we create tags. So whenever we find, because initially I didn't, or our system, autofocus didn't have an understanding. It wasn't hitting on any tags, and none of the security industry knew about this. Of course, they were hitting the malware as malicious. Everyone was looking at it as, oh, this is a malware, but is this something unique? We didn't know that. So after our investigation and analysis, we know that, yeah, it was a new malware family which has been used by the threat actors since 2011. So what I'm trying to get to is there has to be a better way to solve this challenge, that similarity challenge, right? How can we find similarities in unique sample sets, which is not possible sometimes using import table hash or SSD fuzzy hash. The threat actors know how researchers like us, what kind of methodologies we use. But I think, as we evolve, of course, we have published it, but these kind of techniques should be used more in our industry. That's why I'm trying to share it with you all, that explore these kind of ways. Data science has a lot to give to us, especially in the cybersecurity community, so play with it. But we are going to talk a bit more in detail in the next half an hour or so, which we have now. So similarity analysis, typically malware reversers, malware analysts, the first thing they would do is when they encounter a unique malware, which is unknown, is load it up in a disassembler, look at the code, look at, if any functions match any known malware family. So let's say, I used, or they can use IDA, bindiff. It's basically a plugin for the disassembler where you can compare two different malware samples one-to-one and see the difference. So I actually, just going back, I used the two same malware samples to do the differential analysis, bin diffing the two samples which I was investigating. So here I can see that there was a function. Of course, majority of the code was similar, but something was unique. So when we look at it on a chart, it creates a flow chart. You can also look at it from a code perspective, but also on a high level, it gives you some understanding. So you can see here, in one of the samples, there was a small change. So that was that created the uniqueness, but otherwise it is very similar. That's why. But looking at this, we are able to kind of ascertain that these two samples are likely the same malware family. However, as I say it on the slide, that this doesn't scale. For example, let's say you have hundreds of samples or thousands of samples, and you want to do differential analysis. You can't be loading each and every sample. Like, let's say there are 100 unique unknown samples. Are you going to load it up? It's a big challenge, and malware analysts have been spending, or I would say it has been a waste of time. Something very simple, but it's a waste of time to do similarity analysis like this. Of course, many people are playing different ways, like they are trying to create some kind of hashing or some kind of signature based detection using IDA, but still I think that is still more time taking. So there are other techniques which we are going to explore today. So when we are talking about similarity analysis, and I've created some graphical representations which really makes this complex subject easy to understand. So when we are talking about similarity, again, we are talking about similarity between two samples, like one-to-one, right? So sample A, if I want to understand what is the similarity, I really have to pinpoint, okay, the color combination is all white. It should have been because I was just making some modifications, but we are looking at all these samples to be the similarities between this sample A and sample B, right? Um, so the same concept, if we are looking at from a malware perspective, we need to understand what are these features. So all these dots, if you see here, these are all different feature sets. So the ones in the middle, if you can see, these are the dots which are common to both the samples. So how can we identify these commonalities? And to identify that, we need to kind of measure it based on features. So from a malware perspective, what kind of features can be used in our algorithms? And these are the building blocks of machine learning. And we are not going to talk about machine learning. We are just going to purely talk about data science algorithms. Again, data science algorithms are building blocks for machine learning, right? So, and it can definitely be used to um, to to um, in conjunction, or uh, to make your machine learning models determine better, because the more feature sets you have, I wouldn't say the more feature sets, the more data sets or the more features you have. A lot of times, if you have too many feature sets, sometimes the algorithms may not give you the right results. So you really need to understand which features would be effective for you. So from a malware PE file basis, again, there are document-based malwares, and PDF-based malwares, and there are different feature sets which you can extract. And again, PCAPs we were discussing, different completely. But for our perspective, I'm specifically looking at PEDLL files, right? So the type of features we can look at is, there are 5 unique, I would say, things which we can look at. Is number one is string-based features. A lot of nation-state cyber threat actors, they don't care to obfuscate their malware, because once you start, if you use some kind of encoding encryptions, it increases the size. So they are more focused on efficiency than they want to hide things. They don't care. So a lot of times it is not obfuscated. So in those attacks, sometimes you can use string-based features. Import address table. So again, I won't get into the details of what is import address table, but it is similar to the import table hash, and you can use those kind of features. And then there's the PE header feature. A lot of times we have seen some threat actors use false flags. But again, PE headers can be a unique feature which can be used as well. Instruction sequence, assembly language features. Of course, that means your data set will be much higher, but you have to see the pros and cons of each data set. Again, dynamic analysis. Maybe all the reports from your sandbox, open source sandbox like Cuckoo, or commercial sandbox like Wildfire, which we have. So for our understanding, I'm going to look at string-based features, very easy to extract. And the algorithm of choice, which I've used, and it's been amazing, is the Jacquard index algorithm. So I know we'll talk a bit of math now. I've not been great in I've not been great in math during my school times, but I'm more interested now. I really wish I understood applied mathematics more during school. This would have helped me a lot in my current field of work. But again, never too late. And I'm really excited about math these days, because how just seeing how math can be used, simple mathematics can be used to solve my field of the challenges which I have. So I'm very excited about that. So what is Jacquard index? So Jacquard index basically measures similarity, and this is the formula. So as you can see, the formula says similarity of A comma B. That means set A. This gets into sets and matrices. College math, but it is very simple to understand. So similarity of A comma B, that means similarity to, what is the similarity between set A, and what is the similarity between these two sets, A and B? the answer to that, or how do we find the answer, is A intersection B divided by A union B. So I know a lot of us have forgotten what is an intersection, what is an union. So I have a slide to explain that. So what I mean by A intersection B is this middle portion. The commonalities is the number. The A intersection B is defined by this middle section, right? And A union B means the middle section plus the section which is not common, right? So that means A intersection B will always be smaller than A union B, because union includes all the other things which are also outside of this intersection. Let me make it much more simpler in the next slide. But I just wanted to say that the answer, let's say A intersection B, if it is smaller than this, the value will always be between 0 and 1. Let me show you. Let's say A intersection B divided by A union B, the result is always between 0 and 1. That means, and I'll make this a bit more easy in the next slide, but this is the similarity scale which data scientists, machine learning people usually use. That means if it is on matching 1, the value, if you get the response is 1, that means it is 100% matched. But if you are closer to 0.1, that means lower similarity, right? I know it can be a bit confusing, but these examples will make this concept much more easier to understand. And I know this can be a bit dry and boring, but trust me, these examples you'll never forget this, basically. So once you understand this, you will never forget this. And when you're writing your own algorithms or trying to solve your own work, you can define this, or this will be very useful. And it was dry for me when I was doing it initially, but I think this was very useful for me. So from a malware perspective, let's say there are 2 malware samples, 10 features each on this sample, right? So what is, let me put this here. So what, just having my formula up on the right hand corner there. Oops. So in these 2 samples, what I'm saying is there is no similarity. That means all these 10 features are completely unique. And this is one instance where, excuse me, where sample A is completely unique to sample B, and there is no, there is no similarity between these 2 malware samples. That means our value of A intersection B is 0. There is no intersection between these, right? And then A union B divided by 20. That means the rest of the values is 10 plus 10 is what? 20. That means my value of is 0. That is similarity of A and B is 0. Let me go back to my scale, the previous slide. You see here, if it is 0, my similarity score is complete here. After this, that means there is completely no similarity. Let me go back now. So as I say, the total attributes of these feature sets is 20, 10 plus 10, common attributes 0, Jaccard index score is 0 when we are looking at from the scale perspective. Now, the next example is all the 10 samples are matching. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a complete match. That means A intersection B is what? 10. A union B is also what? Intersection plus the rest. The rest, there is nothing. 10 divided by 10. What is the score? The score is 1. So that means my Jaccard index score is right from on a scaling perspective. It is right on the right hand corner. If I go back again to this slide. So that means it is a full 100% match, right? So now let's take something in the middle. That means out of the 10, there is only 6 match. And 6 divided by 14, this is 0.4. So it's not like, this is the Jaccard index similarity score when there are 6 attributes which matched. And then 6 divided by 14, you are getting that value. So this is the Jaccard index value. I know I've taken too much time, but I think this is quite important. Now we are done with the concept. Let's look at the real world case study. So as I said in the start of the talk, I heavily focus on the Asia Pacific region, and I was, of course, we look at Middle Eastern campaigns and all of that, but in this particular talk, I've used some of the threat actors, like Ocean Lotus. I've been talking about Ocean Lotus and oil rig quite a bit in this presentation. So Ocean Lotus is quite active in the South China Sea region, right? One of the primary reasons which I think, and again, as an intelligence guy, we should always not be making too many decisions in terms of what is the main reason. Of course, this is likely the cause that, there is a lot of dispute in this part of the globe with respect to some countries saying this part of the sea is mine, another country saying that part of the. So there is a lot of dispute in the region, right? And one of this actor actually originates from this particular region in the ASEAN region, and this is Ocean Lotus. They have been quite actively targeting actors in the Asia Pacific region, but as I was saying, they have gone global. So even if you're in Saudi Arabia, you need to understand how this group works, because they have taken their operations. I would say we have seen instances even in the Middle East. So it's not like, again, only focus on oil rig. As I said, as an threat hunter, you have to have an understanding of the global scene, but of course you have to prioritize which actors you need to look at, but definitely be aware of all these different actors which are very active. So Ocean Lotus has been heavily reported for a long time now. This is one report from ESET back in 2018. We published Unit 42 publication on macOS backdoor, which was published on 2017. I had published together with my colleague Hayashi-san earlier last year on this group Kurdown, and which I've been discussing now, because I think it is a very good example to learn about how to track using certain concepts which we have been discussing, right? So this group have been heavily reported. So I showed you all about the blog and how we started. This was the document file with an embedded macro. Of course, they are not always using a macro. They are completely sending directly the malicious DLL executable, and now they are using exploits as well. So which they have used quite extensively. But in this campaign, they were using a macro doc. And the first look, as I was telling earlier, that it looked like a small line, but it was very unique because I've never seen an entire piece of DLL actually copy pasted. It was very simple, but actually it did a job, because a lot of times if it is embedded within a macro, within a document file, a lot of scanners can detect, okay, if that is a shell code, there's a DLL file, it can detect. I don't know. If it is copy pasted, maybe it didn't go through our defenses, because Wildfire, as I said, it was able to detect the malware as malicious, but initially we didn't know which malware family it was, so we started looking. Again, I won't go through too much, but as I said, we had hundreds of samples, and this snapshot was taken last year, and you can see here SSD fuzzy hashes. Some are common, but many are unique. Most are unique. Again, you can see here import table hash. SIGs has common, but many, it keeps on changing. So the import table and SSD are not really ideal to track these kind of campaigns, because it's going to be very manual. We can't just focus on a single import table hash. What this means is I have to keep tracking of all different import table hashes, all different SSD hashes, which is really time consuming. It's not pragmatic at all. And this is where Jacquard index algorithm was amazing. It was just incredible. Trust me, I was super happy. So what I did was I extracted all the suspected samples. When I was investigated, I found a few hundred unknown ones, which I thought may be related, but I wasn't sure because it wasn't hitting any of the tag. And doing manual analysis I would have done it, but I was again exploring newer ways to explore how I can reduce my analysis time. Now extract all the known ocean lotus samples. That means different malware families which I know, right? So I had these unknown ones and I had the known ones which I know. So I wanted to mix up my pool of all the malware samples I've been tracking of this specific threat actor group. Then I extracted string-based features because I saw they were not obfuscating them. Extracting string features was super easy. Then I applied the Jacquard index algorithm. And again, when I do it using a Python script, it just automates that matching or comparing the samples real fast. And then I used the network X Python library to visualize my analysis. And guess what happened after I did all that? I used GraphViz to visualize this after I plot that. And this is what happened. This basically, when I got the result, it was magic to me, and I've used this GIF quite a bit on this research and talk, even at RSA, because I was super glad because what I got was actually magic for me, because I wouldn't have been able to get the result in such a short period of time. So here, if you see, this is the result. So once I ran it, you see on the top right hand side, there was a big, huge cluster. And I've just noted new family there, because when I had this, I didn't even name the malware family. I didn't, it was just unknown, and it created the big cluster, which I was kind of hoping that I get the cluster. And you see all the other cluster, which is known, like windshield, bad cake, windshield, they were creating the different clusters. So when I had this cluster, that means I was very certain this was a completely unique malware family, which does not match the known ones of this threat actor group and many other threat actor groups, right? So I was very sure that this was a new family. Okay, going ahead, what do we do next? So once I found this cluster, there are amazing patterns to extract now. So what I did was I started looking at compile timestamps now. So now I have all the sample sets which are unique, and I wanted to understand since when they have been using it. So this stat is a bit outdated, but they have been using it since early 2018, and they are still using it, because I gave a talk at RSA, and this is the the chart which I had plotted. And as you can see, they have been increasing their usage of this malware family, which I named Down later. This is one of the amazing chart, because once I actually know that Ocean Lotus operates from the ASEAN region, right? There has been a number of reports. Again, if you go to MITRE's attack website, attack framework, or attack.mitre.org, there are so many reports that possibly also some have alluded to which where they are probably based, but again, trying to be just sticking to our operational and tactical information, we understand that they are operating from the ASEAN region. So what I did was I plotted all the compile timestamps using +7 time zone, right? This is the time zone I plotted, and I see that all the samples were compiled between 9 a.m. and 6 p.m. You see this is a year's worth of data. If I had only few samples, and if I wouldn't have had this similarity, if Jacquard analysis or Jacquard index didn't give me that similarity of all these samples, I wouldn't have been able to get this. So now that has enabled me to understand that all these malware samples were compiled between 9 a.m. and 6 p.m. Of course, there was 2 samples which was compiled at around close to like about 7:45, and this was about 9:45, I would say. So that maybe some one or two of them may have worked overtime, right? But this is an amazing chart which tells me that these guys have a 9 to 6 job, right? This is an incredible finding. Nobody, there has been a lot of reporting on Ocean Lotus, but none have had this kind of visibility, which actually shows that they actually have a 9 to 6 job. That means they might be going to an office. If it was working from home, a lot of, I doubt that we would get such a clear pattern, right? And again, trust me, this is nothing made up. This is exactly the data I have. There is some fun stuff later on. You see, now when I plot the same data to find which days of the week they work, it is amazing now to see that they actually work from Monday to Friday, a very typical working days of the week in this part of the world, where people start their work day on Monday and finish it on Friday. And don't we all like love getting close to the weekend? And even these guys, you see, on Friday their effort or their performance goes down. But again, this is a fun thing, but it is incredible to see the previous slide that they had a 9 to 6 job, and this slide shows that they actually have a Monday to Friday job. So this is really reassuring that they actually go to office, I would say. Again, this is all the data which is, these are all the patterns we are extracting out of that data. And I really thank the Jacquard index algorithm to give me all the similarities. Without that, I wouldn't have been able to find this pattern. Now, so the interesting thing is, I published this research at RSA conference. Sorry. Of course, I published it at the RSA conference, but actually I went public with a blog. I showed you all the blog which I published. So as soon as my blog was published early around Feb last year. So what I did is, since Feb of 2019 and until December 2019, I extracted all the known cut down samples which we have been seeing. And guess what? I wasn't surprised. They started changing, because I'm sure they read my research, and they started changing their compiled timestamps. Again, this was expected. I knew as soon as my research would be published, they would know that we were able to find certain mistakes they did in their OPSEC, and they are going to change their timestamp. And now I don't have a pattern of that 9 to 6 job, right? So here you can see it is all over the place. That this doesn't mean that they are actually working 24/7, but this means that they are actually manually changing their compiled timestamp. They have been doing it with many other malware families. It was just a matter of time for them to change it, but they overlooked Curdown, and some of them, whoever are the developers of the Curdown malware family, they made a mistake. And from our perspective, we are always looking at how to find the mistakes of the bad guys, and then using that mistake, find patterns in their operations. So again, even I understand they are changing it, but I don't care. At least we have an understanding of their work times, right? So absolutely no, these guys are not working 24 hours a day. And they also made sure that they are compiling those, they are using days from Sunday, also including Sunday, Saturday, all days of the week. And do you think that they are actually working all 7 days a week? No, they are all changing it, right? So really hardworking? No, I don't think so. Okay, I'm going to skip this because this is again another example of a syscon malware which was being used to target certain US government agencies, and there we found similarities on that as well. Just another example. Again, this was interesting to see that once we get this kind of similarities, even with different malware families, I was able to find that once I find these similarities and see the work pattern, you can see the actors, they are very effective early days of the week, and as they approach weekends, their performance goes down. But these guys actually may be working during Saturday and Sunday, but the effort is not. The numbers are pretty low. Performance is down, down, down. Okay. So, anyways, okay. I mean, this is what I had. I think we did what, almost more than 2 hours now, I guess. So there is a ton of things which I shared, a lot of things in terms of what kind of building blocks you should be referring to, some of the frameworks. I'm just trying to kind of summarize what we did, like, the building blocks with respect to the kill chain, the attack framework, hugely important, the diamond model, if you are getting into the defensive game. It is amazingly interesting, trust me. A lot of people I talk to, the upcoming cybersecurity professionals, a lot of them are into bug hunting. Yes, it is great. It's great to find loopholes. And when I started my cybersecurity career almost 18 years back, it's been a while, 16 formally, I guess, and 18 overall. Of course, I wanted to do offensive security, find vulnerabilities, do pen testing work. But as I learned about the defensive game, I was very fascinated, because if I'm a defender, I can learn about the real world cyber attacks, what is really happening. And that knowledge is going to help me defend organizations, uncover cybercrime, create defensive capabilities to defend against these sophisticated cyber attacks. So I think defense is for me, I'm very passionate about it. So if you all are, even if you are doing offensive security, knowledge and understanding of defensive, these kind of the topics which we shared is immensely going to help you. But if you really want to come into the defense side of things, doing threat intel work, doing threat hunting work, incident response, what we discussed with respect to the frameworks and some of the tactical tools like Yara, Jupyter notebooks, Suricata IPS. These are very just, again, it's just 2 hours I took, but the topic is enormous. But my main goal was to give you all some bits and pieces of how exciting this journey is. So many of you can consider this and play around with it. There's a lot to be done, right? So I'm going to stop here, and I'm going to repeat again that if you have any questions, feel free to reach out on Twitter. That's the best way. Of course, I have LinkedIn. You can connect with me on LinkedIn, but I'm not very active on LinkedIn. Twitter is easier. A lot of us are active on Twitter. I don't post so much. I know there are lots of people who are much more active on Twitter, but Twitter is the easiest way to reach me. So if you have any questions, feel free. I know it is very late. I think it's going to be midnight in Saudi Arabia, and it's Ramadan time. So I really thank you all to dial in this late, and the Cyber Hub team to organize this conference. It is great. I wish during our times we had these kind of exciting initiatives for us to learn more. But I'm much more happier that I'm able to share back to the community. So again, I forgot to greet you all earlier in Arabic, but I would like to say shukran, and have a good Ramadan. And if you have any questions, feel free to reach out to me. Masalam. Thank you.